Welcome to AutoSens, the world's leading community for ADAS and autonomous vehicle technology development. We create best-in-class events, training, and information in order to connect the global community of scientists, engineers, and other automotive industry experts. One such industry expert joining us is a longtime member of the AutoSens family, Daniel Shwartzberg, Director of Business Development and Systems Solutions at Valens Semiconductor. Daniel, welcome back to AutoSens. Good to see you again, my friend.
Likewise, Carl. It's always a pleasure talking to you. Thanks for having me back.
I bet you can read my mind, and I have a feeling that you're not going to be surprised when I bring up MIPI A-PHY. And as you know, it continues to build momentum within the industry, with Continental now announcing a new 8-megapixel A-PHY camera. Daniel, tell us a little bit more about that.
Yeah, I think that's a great starting point to dive in, Carl, because just a few weeks ago, Continental made this announcement that they have now added MIPI A-PHY standard connectivity into what they call their ADAS camera belt. They have a family of cameras, which I think is called the FSC 300. And they've now taken that with the integration of MIPI A-PHY to basically new levels of quality. We're talking about, as you said, 8-megapixel cameras. But in fact, this is an 8 gigabit per second MIPI A-PHY link. That 8 megapixels is fine, but they can even go beyond that. So the A-PHY capabilities now take them to 8 megapixels, and as I say, even, for example, up to 15. And this really is a huge announcement, because this is a forward-looking. When I mean forward-looking, I'm not talking about a front camera. I mean, from a vision, and that's probably not a good way of saying it either. From a conceptual point of view, it's a forward-looking camera platform for highly automated driving systems, as we think about higher and higher levels of ADAS. So these are the sort of camera platforms that are going to be needed. It's a delicate balancing act between performance of a camera as well as the cost, of course, which is such a critical factor in the industry. And basically, these new FSC 300 cameras are pretty much the eyes for those systems, right? It's highly modular camera, from what I understand. It can take fields of view from as low as 28 degrees up to as wide as 120 degrees. They put in things like lens heating, and as you said, an 8-megapixel camera to begin with, really offering very, very high resolution from a multitude of different applications. And if you look at what they'd said, and I'm probably going to just paraphrase this because I don't remember exactly word for word, but basically they're saying that what the MIPI A-PHY standard gives them, it ensures them the lowest error rates and enhanced performance, enhanced EMC robustness, enhanced performance of the link in the extremely harsh automotive electromagnetic environment. And of course, what that means is they're saying that their cameras now are very resistant to the external interferences, and are therefore reliable in various different conditions that the automobile is experiencing. So in other words, for them, this represents a game changer in terms of the quality of the systems that they can support, the quality of the vision that they can provide to the ECUs, and of course, all made possible with MIPI A-PHY technology.
And we know, Daniel, that right now Continental is just the latest, but we've also seen Sony and Black Sesame make headlines with A-PHY technology. So what are your thoughts there as we see more and more companies coming online with A-PHY?
Absolutely, and you hit upon another two very, very major players in the industry. Sony Semiconductor Solutions, of course, are leading, one of the biggest, if not the biggest, sensor module companies in the world. Now, we announced already, wow, probably over a year and a half ago, that they were working on integration of A-PHY directly into the sensor. Now, this is a key benefit that having a genuine standard in the industry brings, right? Integration is only possible with standards, because anyone who has access to standard can develop, right? Proprietary single source technologies are not standards. There are certain companies that make them, but nobody else has access to the technology. MIPI A-PHY is a true standard brought to you by the MIPI Alliance, and also, by the way, adopted by the IEEE. And so this enables companies like Sony to develop the silicon to do the integration of A-PHY directly into the sensor, meaning that in the camera, you will not need a separate serializer transmitter chip, meaning the camera can be smaller, lower power, less heat to dissipate. And these are all things that are critical when we look at the ever shrinking form factors of automotive camera modules, automotive cameras. So basically, yes, we made this announcement with Sony a long time ago, but more recently, Sony announced that they have completed EMC testing, the all-important EMC testing of a multi-vendor A-PHY link. So in other words, what that was their silicon on the transmit side, the Valens receiver chip, the deserializer chip on the other side. And they went and tested EMC in that setup. And wouldn't you believe it, everything just passed perfectly. And of course, that's another thing that's the beauty of a standard, is it's interoperable from different vendors. So of course, we would expect the link to work at the very minimum. But as I said earlier, one of the key highlights that Conti drew out was that EMC robustness. And here we see it being proven out in real world testing between Sony and Valens, a true multi-vendor link, passing the all-important EMC testing. So that was a huge announcement as well, and very, very exciting for the industry. Again, the ability to make those cameras smaller with less power, less heat to dissipate is very, very, very important. So that was one announcement on the camera side. You also mentioned Black Sesame Technologies. They're an SoC, a very, very advanced SoC vendor coming out of the Far East. And they are looking at the other side, right? At the platform side. Sony on the sensor side, Black Sesame on the platform side. And they announced that they have basically enabled the integration of A-PHY connectivity. And I'm sure I'm going to get the name or the pronunciation of their platforms wrong here, but I'll try my best, into what is their Huashan, I believe, Huashan to A1000. Autonomous driving computing chip. And in fact, that's not enough of them. They're even going one step further and in the process of adding it to their Wudang C1200 intelligent vehicle cross-domain compute platform. Okay, so these are the sort of processing platforms that the industry needs in order to get to these high levels of ADAS onto the eventual goal of autonomy. And again, Black Sesame are now very, very well positioned, bringing extremely complex silicon to achieve that, and now with the additional benefits that MIPI A-PHY brings. So yes, you drew out two key announcements of recent weeks, but actually we see the ecosystem of players supporting A-PHY growing rapidly, because we are seeing A-PHY spec'd into more and more RFIs and RFQs, right? So the OEMs start to spec it in more and more. And not surprisingly, when the OEM starts speccing it in, then we see the ecosystem of tier ones, of tier twos, and other players aligning accordingly, right? Because the RFQs, the RFIs mean business, and the tiers behind that business are aligning to it. So it's an ecosystem that is emerging rapidly, and it is broad and it is deep. And what do I mean by that? I mean that it covers all of the different elements that the industry needs in order to bring a new technology to market. So I've mentioned the camera side with Sony, but A-PHY is of course agnostic to the type of sensor. So it's not just camera manufacturers. We see radar manufacturers, we see LiDAR companies adopting A-PHY into their products. So again, all the sensor side covered. We see it, as we mentioned earlier, with that new announcement from Black Sesame, we see the SoC platforms, the SoC side also adopting it. But it's more than just the kind of products that the tiers will develop to be built into the vehicles. We see all of the necessary support beyond that as well. So I'm talking about things like product testing, whether it's verification IP, which allows silicon vendors developing A-PHY solutions to have an off-the-shelf verification tool to test the design before they actually manufacture the silicon. But it's also the product testing equipment. So it's companies that are supplying tier ones and OEM with test platforms and testing software suites that allow the product developers and eventually the OEMs to have equipment to make sure that the systems are working fully before they're assembled into the vehicle, and then of course in the production line. So we see the sensors, the platforms, the component testing, the product product testing, excuse me, but also component development. So of course, we at Valens are the first to bring MIPI A-PHY chipsets to market, but we've heard in recent weeks of a number of additional companies that have announced that they are releasing A-PHY products to market. We've already talked about the sensor integration. The public announcement is Sony. I can't say more than that, but the public announcement is Sony. I'll let you read between the lines. We also have SIP modules as well, system in package modules. So we see not only the products at the system level emerging, but also at the silicon level. The tier ones, the OEMs, will now be able to pick silicon from different vendors, finally going away from what has been a nightmare for them over the last few years. As I've said, the existing solutions out there before MIPI A-PHY came along were proprietary and single source. And if we look at the chaos that the COVID pandemic brought in terms of the semiconductor supply chain and all of the headaches and the number of vehicles and platforms that were not being able to manufacture because companies could not get silicon from single sources, these are the sort of headaches that the industry can now move away from to a standardized solution with a multi-vendor silicon supply chain, and of course, an emerging ecosystem of products that interoperate from many, many different players.
Daniel, it seems like as we're discussing this, that there's just a long list of benefits when it comes to A-PHY technology. From your vantage point, what is drawing all of these companies? We've only mentioned, the three: Continental, Sony, Black Sesame, of course, Valens, but what's drawing these companies towards A-PHY? Is it this list of benefits? What's your thoughts on that?
Yeah, I mean, and again, I have just given, and we've talked just about a few names. Anybody who was at CES would have seen a whole range of products well beyond what I just mentioned that happened to be in our booth. But it's a very, very good question you asked, because obviously there is a reason why companies are rushing forward to adopt this technology. And I think let's start from the top, of course, and we talk about the OEMs who are looking to get to higher and higher levels of ADAS, the different levels from 1 through to 5, which is, of course, the eventual fully autonomous, hands off, brains off, minds off, everything off, no steering wheel and all of that. Now, of course, we're not there yet, but there are a number of phases on the way to get there. And in order to do that, what do they need to put into their vehicles? That's more sensors, and also different types of sensors. I mentioned radars, I mentioned LiDARs. People think maybe of cameras, but of course there are more than just cameras. So they need more of them. They need a variety of them. They need higher quality. As you know, as basically the car does the driving rather than ourselves doing the driving. And we need to get to higher and higher resolutions. We need to have to pick out maybe very, very small objects in front of the vehicle or around the vehicle that maybe our eyes are able to do, but existing sensor resolutions have not been able to do so. So we're moving to better quality of radars, wider of cameras, of radars with wider fields of view, longer distances, and so on and so forth. So more sensors, different types, better quality, and of course sensor fusion, right? So in other words, if we think about ourselves, we have our eyes, we have our ears, and we use both of those in order. If you're walking around a busy shopping mall, you're listening, maybe somebody's behind you, you're using your eyes to see what's in front of you, and together that avoids us bumping into people. Translate that onto what's happening on the road as we move to higher levels of ADAS and eventually full autonomy. So we need to be able to make benefits of the different values that each sensor can bring. So cameras maybe are good when the weather's good and we're in daylight. Maybe we need radar and LiDAR when the conditions are worse, and whatever. But we want to be able to merge all of that data together, right? We want to be able to enjoy the benefits that each one brings. And as I said earlier, A-PHY is agnostic to the sensor type: cameras, radars, LiDARs. So it's all just data that the MIPI A-PHY standard knows to extend. And that means that sensor fusion is basically a given, right? It's very, very simple to achieve. And finally, I think if we look at the changing architectures, we see a move from distributed architectures where we had hundreds of ECUs, or maybe not hundreds, but over 100 ECUs distributed around a vehicle. Now the industry realizes, the OEMs realize they need to move to a centralized processing architecture, and that requires a lot of data to be fed into the center. That requires high bandwidth, low latency, extremely robust data links. And that is exactly what A-PHY gives them. So yes, standardization are put aside from a technology point there's a lot of benefits that A-PHY brings, and this is why we see these companies rushing to adopt.
And let's go from there, Daniel. You mentioned these new architectures. You mentioned there has to be more sensors and more cameras. And ultimately, if we want to do hands-off autonomous driving. So the main technological benefits of A-PHY, what's your thoughts and perspective there?
Well, there's so many, and you and I have talked about this in the past, and I could
Indeed.
easily go off on a 2-hour lecture now, but I won't. For your benefit and the benefit of anybody watching. But basically, yeah. So again, we've talked about the benefits standard brings: multi-vendor, interoperable integration. Let's put that to one side. A-PHY brings a lot of other benefits at the technology level. The first is that this is unlike legacy solutions, which are, shall we say, analog technology based. A-PHY is a digital technology. So it's DSP, digital signal processing based, DSP based. And what that means is we have mechanisms on the receive side that allow us to recover the data very, very efficiently and very, very successfully, extremely high performance in that harsh automotive electromagnetic environment that I mentioned earlier. So it's a digital implementation. And now those DSP algorithms are actually implemented as hardwired algorithms in the silicon on the receive side. A-PHY actually simplifies that way the transmit side, which makes the integration that I was talking about, Sony being the first to do. The integration on the TX side is therefore much simpler because the heavy lifting is done on the receive side. So A-PHY was designed for the ground up for simple transmit side, making integration so much easier for the sensor vendors, for the silicon guys doing the sensors. It's also a very scalable technology, high bandwidth technology. So in other words, if we look at A-PHY spec 1.x, I'll call it, 1.1 was the latest version, that defined a downlink speed from sensor to ECU of anywhere from 2 up to 16 gigabits per second. Spec 2 already brings us 32 gigabits per second, and then there's a roadmap to go to 48 gigabits per second as well. So it's the same technology that you can use from 2 gig through 60, 32, and eventually up to 48 gigabits per second. Okay, now that is a lot of bandwidth. Brings me back to what we said just a few moments ago. Centralized processing is going to need all of that bandwidth to get all of that great sensor traffic into the high performance compute elements. So very high bandwidth in the downlink. Now, another benefit that A-PHY brings is that it is designed from the ground up to be asymmetric as well. And if we think about sensor traffic, sensor bandwidth, we get a lot of bandwidth from sensor to ECU. We need very little in the uplink. So A-PHY was designed always to be asymmetrical, and actually in its current version, it's either 100 or 200 megabits per second in the uplink. In future versions, that will increase. But that asymmetry is what a sensor demands, and that asymmetry brings benefits in terms of the fact that because I'm no longer running a high bandwidth uplink that I don't need, I'm saving power, I'm saving silicon size, and all of these things are, again, very, very critical when we look at silicon, when we look at integration. So yes, it's asymmetrical. It's not like some kind of Ethernet technology, which is symmetrical, that you need to try and adopt and force it to be asymmetrical. No, designed from the ground up to be asymmetrical. And of course, I come back to the final point, which I've said a few times now: EMC robustness. So important. These are mission critical data links, right? These are cameras that are being used to feed data to processing elements that are driving the car for me. This is mission critical, safety critical stuff, right? So A-PHY brings a packet error rate of 10 to the minus 19. That is hugely robust. And it depends how you want to do the maths, but this is one packet error every several tens of thousands of years for typical usage of the link. That is several orders of magnitude better than what existing legacy proprietary solutions are doing today. And again, that means that now the compute elements are receiving guaranteed good data. That means that the algorithms in those processing elements no longer need to worry about having to do error correction and stuff like that. They know the data they receive is good. Makes the life of the folks who are developing the software running on those high performance compute elements so much easier. So yes, it's a standard, but it's a standard that brings so many technology benefits to all of those who are using it.
We're speaking today with Daniel Shwartzberg, Director of Business Development and Systems Solutions at Valens Semiconductor. a longtime member of the AutoSens family. In addition to being an expert in all of Valens's solutions for the industry, Daniel is also one of the world's foremost experts on A-PHY technology and its applications. Daniel, will we see legacy OEMs move towards A-PHY and embrace it?
Well, the million-dollar question, right? So I think the automotive industry is kind of a little bit unique in that it is fairly conservative, right? And they like to tread fairly slowly. Some will go a little bit faster, but I think in general, things tend to happen slowly. Now, I wish I could tell you what I want to tell you, but I'm not allowed to because there's confidentiality clauses and things. But let me just say that we're in many processes with OEMs all around the world. Okay, we're in processes with OEMs all around the world regarding A-PHY technology. You will appreciate that the speed of which the ecosystem emerges, as I said earlier, gives you some indication of the interest at the OEM level, right, to get A-PHY technology. So like I say, and I'm biting my tongue here, I can't say too much at the moment, but I think we're going to be announcing some big things pretty soon. Okay, so let's just leave it at that, Carl. And I wish I could say more.
Daniel, I've got to give you a compliment because last AutoSens and in-cabin 2024 in Detroit at the Huntington Place in downtown Detroit, I was over at your Valens booth, and you showed me how that when noise gets introduced into a system, those mission critical safety systems, and how that camera becomes distorted, and what do we do if noise gets in and that camera is attached to an automatic emergency braking feature, and like you said, mission critical stuff. And when I walked away from that demonstration you gave me at the display, the light bulb went on above my head, and I went, ah. And then for several days and for several weeks, and even it's been a couple of months now since we've had our AutoSens event here in Detroit, I come back and I think, Valens is really onto something there. A-PHY technology, they're really onto something there. So one, I want to give you that compliment that demonstration you gave me, even here a couple of months later, is still in my head where I'm like, wow, Valens has done it again. But going forward in Barcelona now, will we be able to see A-PHY in your booth? What will you be showing us in Barcelona at AutoSens?
So first of all, thank you for that, Carl, and I'm very happy that you took away such a positive view of that demo. And I just have to tell you that just a few weeks after AutoSens, I was back in the USA with a number of demos, including that one.
Mm-hmm.
We went to OEMs and we went to tier ones, and I think there was not one person who saw that demo who was not blown away by it. Okay, it is hugely impressive. It drives home the limitations of existing technologies and brings forth so clearly the advantages that A-PHY brings. So not surprisingly, yes, at Barcelona, we will be showing that as well. But again, the focus at Barcelona is going to be on the ecosystem, okay? We're going to have quite a showcase of products within our booth from vendors, some of whom I may have mentioned earlier and others who I haven't. So you're going to actually see the ecosystem in real. You'll be able to touch it, you'll be able to hold those products. They're going to be in our booth, but also not just in our booth. What people will be able to see on the show floor at AutoSens will be many other exhibitors also showcasing A-PHY technology, companies like Samsung, like Nextchip, Mobileye. So you're going to be able to see products not just in our booth, but elsewhere on the show floor. And I think that's really going to, show that, okay, yeah, we'll have that tech demo as well. But when you actually see the wealth of product out there with A-PHY support, I think that's really going to leave another very lasting impression on you. And some of those companies, I should also mention, you can go to the MIPI.org website. Over the past few months, a number of pretty big names have joined the MIPI Alliance, right? Companies like Ford Motor Company, massive OEM joined the MIPI Alliance back, I think it was in March or April, and many other players as well. So again, this ecosystem comes from the MIPI Alliance, which has some some 350 plus members, somewhere between 350 and 400 members. We see OEMs in there, we see tier ones in there, we see tier twos in there, and you're going to see not a small number of those products on display at our booth and also on the show floor.
Speaking with Daniel Shwartzberg, Director of Business Development and Systems Solutions at Valens Semiconductor. Want to just encourage all of our AutoSens viewers and attendees to visit the MIPI website that Daniel mentioned to learn more about A-PHY technology, and then also the Valens website to learn more about the VA7000 series as well. Daniel, thank you so much for taking time to do this interview, and I'll look forward to seeing you in Barcelona, my friend.
Thank you.
For more information on Valens and to find out more about our upcoming events, see the links in the description. And for more in-depth interviews like this, subscribe to our YouTube channel and follow AutoSens on LinkedIn. In Detroit, on behalf of AutoSens, I'm Carl Anthony.